Hello and welcome to the Midterm number 2 review. My name is Dr. Owen Redwood, and this is part of the Offensive Computer Security 2.0 Open Courseware, hosted by HackAllTheThings.com. This review will go over exploit development concepts, network hacking concepts, web application hacking concepts, all relevant to the midterm, as well as a review for the big picture topics and what you should finally expect. Reverse engineering will not be on the midterm. It was adequately covered in the previous homework and exam. You should be very familiar with stack overflows and how to exploit a basic buffer overflow. You should be familiar with format string bugs and exploitation. You should know how to be able to leak values off the stack and arbitrary memory addresses and how to write arbitrary values to arbitrary locations. You will not be expected to be able to do it by hand. So %n allows us to write to an arbitrary address, which allows you to overwrite, say, jump slot entries in the GOT to point to your shellcode, or function pointers in NTDLL if it's writable to point to your shellcode. You should be somewhat familiar with heap overflows and generic heap unlink exploitation. The general exploitation of this linked list macro, which we covered, I think as early as lecture 3, if you need a refresher, for the first half of that lecture, if I recall correctly. At least on a conceptual level, you should be familiar with the features that attackers relied on that were attacked by exploit mitigations. So for shellcode and classic payloads, the nature of relying on fixed addresses of stack and executable segments was changed with address space layout randomization, function pointers being at well-known locations, which were a common target for arbitrary memory writes. It's important to note that this is still a huge problem with the Linux ELF format global offset table. You can still target, in many cases, if there's just partial rel-row, function pointers at known locations in binaries. Next, heap allocation. Algorithms that trust the heap metadata. Safer heap unlinking algorithms were implemented later on by various compilers to defeat various heap-based exploit techniques. And finally, allowing executable data on the stack and heap was changed by the policies of NX and DEP. So exploit mitigations came about around 2004 with Windows XP Service Pack and additions to Red Hat. Some operating systems and hardened distros had mitigations before these times, but it was not common. The implementations of each of these mitigations, especially NX and ASLR at the initial stage, was very weak and still incredibly easy to bypass. This is a more in-depth table. You're not going to need to know this for the exam, but it shows a interesting picture of the evolution of exploit mitigations for Windows operating systems going up to 2008 in Vista. And nowadays we have EMET or EMET. Some people call it EMET for whatever reason, but it's the Exploit Mitigation Experience Toolkit. So, there are mitigations for detecting memory corruption, namely stack cookies and heap metadata checkers to detect memory corruption on the heap. And there are exploit mitigations to defeat common exploit techniques and patterns. DEP, ASLR. There's also variable reordering to combat limited memory corruption bugs, exploits, where you can only overwrite, say, 4 bytes on the stack and you can't overwrite the return address, but you can overwrite nearby variables. This, in a sense, mitigates the exploitation of that in some cases by making it less predictable. Next, you should be aware of what aspects of the system are responsible for implementing each exploit mitigation. This is a copy-pasted screenshot from the previous slides on exploit mitigations. I had to make a correction. ASLR should be included in the Venn diagram of linker compiler because if, say, on Linux systems, position independence is not supported. In other words, if the binary is compiled with no pi support, ASLR cannot be enabled. So there are many libraries and binaries that are delivered to customers and offered to the public that are not compatible with ASLR support and do not support it. So it offers no mitigation there. Stack cookies are compiled in by the compiler. You do not have to worry about safe SEH and SEHOP. That's a Windows land mitigation that we're not going to cover on the exam. There's a difference between a software-only DEP and hardware-assisted DEP, and that's distinction is the presence of a hardware-based NX bit, which is typically a feature provided by the processor. And interesting thing to note is that for jailbroken phones, the jailbreak process in the new kernel usually disables support for almost all of these mitigations, at least ones that are controlled by the OS, so you get no ASLR, no DEP, which makes them incredibly easy to exploit. You definitely need to know what DEP and NX is and how it mitigates certain attacks. You definitely need to know what ASLR is and how it mitigates certain attacks. Hint, hint, nudge, nudge, wink, wink. You need to know what stack cookies are and that they are usually located somewhere in the .data segment. You should be somewhat familiar with my discussion on how in server-side processes that rely on stack cookies and fork to handle a user connection, that fork creates a static copy of the memory space. So it's going to have the same stack cookies, so it allows for the opportunity to remotely brute force a stack cookie sometimes. You should know the basics of shellcode. You should know the restrictions, especially for null bytes and restricted characters given some character filters and some attack vectors. You should definitely know how system calls are made. For exploit development, you should definitely know return to library style techniques. You should be familiar with return chaining and be familiar with ROP. You will not be expected to do them on the midterm itself. For network security, I've highlighted in bold the protocols that you need to be familiar with. That is, at the application layer, DNS, HTTP, TLS, and SSL. At the transport layer, TCP and UDP. At the internet layer, IPv4, ICMP. At the link layer, ARP. You should know the basics of these protocols and what they are used for, their weaknesses, and how they may be abused. You should know specifically about the ARP cache and ARP spoofing and how that enables man-in-the-middle style network attacks. You should know the mechanics behind firewalls, network address translation, or otherwise known as NAT, intrusion detection systems and intrusion prevention systems, and web application firewalls, as well as their weaknesses. The way attackers still get through firewalls is by attacking targets behind the firewall over allowed services. That is typically the realm of utilizing end-day and zero-day exploits. Attacking a NAT is a little more difficult. We won't be covering on the midterm any questions about how to reveal the identity or MAC address or actual address of machines behind a NAT. Um, you should understand IDS and IPS evasion, evading known signatures, polymorphic techniques, and etc., and the flaws of web application firewalls. You should understand stateful firewalls. IP is stateless. UDP is stateless. TCP is stateful, and therefore a state machine diagram such as this is often built by firewalls to detect invalid state transitions, say from any of these boxes to any other box that doesn't have a valid arrow. Even when there is no state machine and the protocol is stateless, there are still ways to check for protocol non-compliance in stateless protocols. But that's not going to be a hands-on topic for the exam. You should be familiar with deep packet inspection and know how to defeat it with session splicing and other techniques. For web application hacking, there is a section in the book that we did not get time to cover in the lectures. If you have the book, the pages 23 through 29, page 35, 64, and 66 through 70 cover a mandatory topic of multi-step validation and canonicalization. Also, we cover in the lectures attacks against admin features and application management. We cover same origin policy and how there are many techniques to bypass it. We cover various encoding schemes. We cover a lot of SQL injection and a decent amount of cross-site scripting. You should, at the very least, come to the exam prepared with the basics of being able to do SQL injection and cross-site scripting, and at least recognizing the attacks live. You should be somewhat familiar with the general approach of vulnerability scoring. For a given vulnerability, you should be able to describe the access vector, the complexity, whether or not authentication is a factor in order to see the vector, confidentiality, availability, integrity impacts, and etc. As for the structure of the questions, it will be true-false questions on the concepts, similar to the homeworks. A majority of the questions on the test your understanding of the concepts, and 10 to 20% will test your ability to apply the concepts. And that is it for the review. Good luck.